Well, hi, welcome to my shop. Today, I think what I'm going to do, I'm going to seize an opportunity here now that the radio is working well. And I'm going to revert back, go back in time to the two tubes I took out. We're going to stick these back in, dry them in the radio, see what happens now. Stick them back in the tube tester also, and test these two guys out. And it may even be the case that I have a substitute for this tube. This is a 6J8. Don't know that it needs to be substituted, but I think that's what I'm going to do today. So why don't we start right off. The radio is stone cold. So why don't we replace, we'll start with the tube that I thought was making all the crackling sound. It was the one that was in this place. Let's stick it back in. Beautiful, beautiful sunny day today. And apparently for son of a gun, that's loose. Sunny, I think we're going to get like 5 sunny days coming in a row. No rain in the forecast. Okay, now this was the clicker popper. Now, changing tubes in a radio like this may affect some of the tuning. So the alignment may be off now. I don't know for sure. I'm not going to worry about that. I'm not going to realign the set or anything like that. So the characteristic of this tube was a lot of popping and clicking, if I remember right. But then, in the long run, I kind of discovered that these grid cap clips were pretty unreliable too. So that's one of the reasons I'm doing this test. Okay, I think we're ready to go. Volume down. Okay, full power right away, and we'll turn up the volume a little bit. Well, so far so good. Turn this down. I don't know what band I'm on. Where am I? Okay, we're on one of the shortwave bands, I think. Let's go down to the AM band. We'll start there. I have so much familiarity with the radio now. Not picking up much. Well, it sounds completely different to me. It sounds like it's working, but it didn't seem to receive anything. So we'll go up on some shortwave bands. So that's 6, 9. Start here. Again, it depends on the conditions on the shortwave band, just how well this will work. So just listen to this for a moment, then I'm going to switch back to the replacement tube. Well, certainly didn't hear any clicking and popping or anything like that. I think I must have been totally fooled at the start by these grid cap connections. We'll switch it now. I won't tune the radio, and hopefully we won't forget what that just sounded like. Let's see how we do here. Offhand, I'd say it didn't make any difference. It sounded pretty much the same, except that AM deal. What happened to the AM side of things? Okay, we're ready to go again. Sounds the same, but quieter. Let's jump down to the AM band. Well, totally different. Okay, so there's a station right there. I wonder if this knob didn't quite connect. Switch rather. So right on AM here. Let's switch the tube back. Let's switch it back. Seems very odd to me that it would work on shortwave. If anything, it worked better on shortwave, but not do anything on AM. That really doesn't work for me in my head. I would think AM is easier, isn't it? Isn't it easier for a tube to pass the lower frequencies? Okay, we're back in. Let her rip. I don't think there's any doubt it works better with the 6Q7. I don't know what happened first time through on the AM band, but it's there now. Well, okay. My suspicions turned out to be valid. It never was the tube. Good and stable too. Ooh, what's that? Wait a minute, what's that? Hold on. Where's that coming from? Oh, I just tapped that tube back there. Not very reassuring. So a microphonic tube, it kind of indicates that the internal components can move relative to each other. what happened to the clicking, but it went away. What I'm thinking about is, should I leave that tube in there now and just go on to the next swap back? Okay, let's do that. So we'll do this one next. Swapping back this Rogers one. You can see that I believe is supposed to be making contact with this outside material here. Let's give it a try. Hot tube. Ha ha ha. Okay. Oh boy, you can. That sound is me just shaking this tube around a bit. That's kind of scary. Things are rattling around in it. It's got a. Yeah, see, I think I squished this. I think I squished it down to make it fit on the smaller cap. Yeah, when you bend these, you really know they're steel. Just get on there a little bit, would ya? I have the feeling I won't be leaving this tube in. Okay. There we are. Are we ready? And this time we're going to start it up on restricted power just to be sure. Yep, no problem. Okay, what are you going to do this time, Mr. Radio? Sounds bad. In my imagination, that's loose components inside the tube. You can hear it dinging, expansion dinging. What is that? Oh, slowing down. Oh. I don't know if you can hear that weird dink sound, but the volume is right down on the radio. Okay. It's just getting a little bit scary there. Okay, so was that this tube we were just listening to? I mean, I would think so. But let's put the other one back in. And we'll see. Some very strange sounds. It sounded to me a little like those submarine sonar that you hear in the old movies when they would send out the sonar pulse. It sounded like a miniature version of that. Okay, back with this tube. Ooh. No, not with that one. Back with this one. Last thing I want to do is get these tubes mixed up, and you know, if there's two things, there's a good chance I'll get them mixed up. Stronger than steel, I am. Did you know Stalin, you all know who Stalin it was. What you probably didn't know is that that's not his name. Stalin was not his name. He had some regular Russian peasant name. And when he became the leader of the Soviet Union, he changed his name to Stalin. Okay, what does that mean? It means steel. Think about that. This man became the leader of a big country, changed his name to Steel. He didn't do it by accident. He was the guy who was going to clean everything up. He was the guy who was going to set it all straight. He was the guy who would become the brute, so no one else had to. He was going to be Steel. Yeah, so he was. Okay, so we're back in here. Turn it back up. And we'll see if any of those weird sounds come. Volume's right down. Oh, jeez. Oh, there they are. All the weird sounds. Okay, it's something else. It's got to be that 6Q7, the other one I put in. Because it's microphonic, right? Okay, power off. Power off. We're going to wear these tubes out just by heating them up and cooling them down. So what about the other? So what about this one? Okay, we're gonna get this one out of here because I think this is the one that sounds like a time bomb counting down. These don't get very warm compared to those little guys. Little metal ones. I don't really know why that would be. Surely the heaters produce the same amount of heat. If you look at that tube, you can see that the grid cap is off center. I have to write to Rogers people and tell them that they got manufacturing problems in their process. Here we are, 6Q7. Okay, so we're going to listen for the tink, tink, tink again. Yeah. Okay, I'm just going to launch this humorous line out there. I'll do the dinging around here. Okay, that wasn't very funny, was it? It's funny in my head. I enjoyed it while it was in my head. I should have left it there. Okay, ready for the tink test. Here we go. All those strange sounds are gone. Okay, so we got to shut it off again. I got to change this one because I'm just too curious. curious. We got a new kitten yesterday here in the house. He's around somewhere. Of course, we have one cat. That, we were a little worried about it, getting along. But of course, our other cat is Peanut, the wonder cat, who tries to make friends with everything and everybody. So sure enough, that's what's happened. The little kitten and our cat Peanut are having a ball together already. So that's the excitement here. Okay. How many times can I bend this? I don't think I'm leaving this tube in the radio, so it's just a temporary deal. Come on. There. Oh, no, not there. There. Okay, so we don't expect to hear any tink or any sudden sounds or anything like that. I'm attributing all that to this microphonic tube here. Ready on the test. Seems a little quieter to me. I think the volume is turned right down on this, yep. No funny sounds, no weirdness. Hear that? Heterodyne stuff? That stuff disappeared at some point in the course of fixing up this radio. Okay, right here. Hear that? What that sounds like? All around 11.8. Otherwise, the radio seems fine with this tube, but I'm thinking maybe that heterodyne stuff is on this guy. Getting a little easier to bend. Not a particularly good sign. So now we have both of the replacement tubes back in the set. Heterodyne. Heterodyne or whatever makes those whistly tones. Okay, what do we hear? No heterodyne. In fact, we're picking up a station now. So I think the heterodyne may be where there were stations, but they're so weak you can't really hear the program material with that other tube. Instead, you hear this heterodyne tone that's being generated probably due to some capacitance issue with the elements inside the tube. I don't know. There's no doubt this radio works better with both of the old tubes out and the two replacement tubes in. is the French station. Okay, so that's great. I'm glad I did that. I am reassured about a lot of things that were notions I have in my head about this radio with question marks after it. I'd like to get rid of as many of the question marks as I can. Now it's time to play tube tester. This time we're going to use my older tube tester. Let me get it. Crowded on the bench. The reason I want to use this particular tester is because it has a noise testing feature in it, which I've seldom used. You can see it right there. It says noise test. And it's what you do is you run a wire. What's that making that noise? Swinging handles and stuff. You run a couple of wires from here to your local AM radio, tune the AM radio between stations. If the tube's generating noise, the noise will be picked up by the antenna on the other radio, come out the speaker. That's the theory. Okay, so let's get the first tube up here. First tube is going to be the 6Q7 tube. Hope it's right here. 6QRS Q R6Q7, there it is. 3 different tests on this tube. It's a busy tube. Okay. 6.3. Sorry, I'm going to do this right in front of you. JR0307. 030. Actually, some of you enjoy watching this, so why am I apologizing? 17. On the bias, 40 on the English. So I have to put on the grid cap. This is turned off at the moment, so I'm not going to worry. Fiddling around. Ooh. What was that? I don't know. It's me imagining things. Okay, that goes on. That goes on very poorly like that. You can't have it like that. Long wire here. Hopefully that won't matter. I got a ton of wire. My little socket here fell out some time ago, and I just have a piece of wire coming up through the hole, and then it's just taped to hold it there. So that's why I'm making that connection. Okay, let's run through it again just to be sure. First of all, most important, 6.3, yes, JR. Okay, so at that point I could turn this on safely because these two set the filament. 0307, 0307 with a 2, 17, 40, press P4, turn it on. Oh, I gotta get this noise thing set up here. Get the noise thing set up. Now that's a tiny little. It's a tiny little. I have a tiny little here. I need a little radio. I need a radio. Hey, is there any radios around? Well, we're just going to try. I'd like to have a little transistor radio sitting right here, but we'll just try the radio I use in my shop all the time.
It really began after that.
Okay, so that's tuned to AM radio. Somehow I got to connect this green wire over there to where the radio is. I have some longer clip leads here. Where are they? It's quite a crazy setup here. That tube's on, too. Okay, no idea if this is going to be good enough the way I've got it. Probably not. I think this actually has to be connected right to the antenna terminal on the radio. A little hard to do with a modern transistor radio. Well, let's give this thing a go now. So first, shorts. No shorts indicated. P4 should read 505 minimum, so just up in here. Ooh, it's a low. That's low. Why so low, little guy? It's not sensitive to the bias at all. So this is testing bad. I can't remember when I tested it the first time. I know there was a couple of tubes that were low. Okay, what about our radio thing here? I mean, this thing could be making all kinds of noises. We got no idea. Hold on, I got a better idea. I got a better radio. I'll use this guy. Okay, it's on AM radio now because this is the antenna lead from it right here. Look at this. It's coming right down from the radio. What happened there, but so there we are, typical AM radio stuff. There's a pretty quiet spot there, so we're already listening to this. Okay, that's good. Do you have to push P4 to make it go? Well, I don't know. There's just no noise. Gee, I wonder if this arrangement has not worked properly. What would be wrong with it? Okay, so in this tester, there's no high voltage applied to the tube until the test buttons are pushed. I'm not pushing any test buttons, so I'm sure I can get rid of this, get rid of this. Terrible. Got a higher reading. I got a higher reading. Got a lower reading. You know why I got a higher reading? No bias, I bet. Watch. Anybody want to try to explain why I got a higher reading there? There. Who can explain it? Because that's now in the operating range. Explain that. Explain that. You can't even see it. Watch. Button down here. Yeah, it looks like I just had no connection here the first time. Ow. That's a crummy arrangement. Okay, so it's actually testing essentially okay. It's me who's not testing well. That's really the situation here. I didn't hear any noise at any point in this whole deal. Well, we have 2 more sections to test. Might as well carry on. Okay, so 0507, 0507, 3, 17, 0, P1, because we're testing a diode now. That comes through on the radio. P1, diode. Oh, that's really low. $17. Wow, that's supposed to be way up to here. Can't imagine the grid affects this. The grid is for the other, like this grid cap is for the other tube section. Wow. Okay, there's one more to test. 0407, 0407 with a 3. Rest is the same. Same low, 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 low. Low, low. Same low, low. Not getting any noise generation out of it though. How disappointing is that? That's very disappointing. It does sound a little different. What about me? I'm generating a lot of noise. This must be the ground side. Okay, let's turn that down. Well, there we are. What do we got? We got the tube testing low on the diode side, according to the tester. And it's certainly not a hot tube on the triode side either. Can't get any kind of noise sort of suggestion out of it. No microphonic sound I could get to come out on the test. Nothing. But when it's in the radio, it certainly is microphonic at that point. I don't think there's any doubt about that. So I think he's done. Should I throw this tube away? I don't think so. I would retain it. Not likely I'll ever have a call for it though. You never know. And now that other one, the 6K. Oh, didn't I have trouble testing the 6K8? Wasn't that the case? 6K7 rather? 6K7. HIJK7. There it is. 6.3 JR. 0347. See, I tested this in my other tester last time too. 0347. 0347. With a 5 at the end. 19 on the bias setting. 66 for speaking English. P4 cap equals G, grid cap. Oh, there's a ton of stuff rolling around inside this tube. Wow. Okay, in she goes. We're done, and it's in there. There's no turning back now. I should have put this grid cap on right away. It's not going to fit on this gigantic cap. That's kind of a hopeless deal. How am I gonna cap the cap? I need like a really big clip lead here. No, it's not gonna make it. Okay. JR 0347. Checking it out. 0347 with a 5. 1966. 1966. In 1966, the American war in Vietnam went from having something like 150,000 soldiers to having something like over 400,000. Soldiers fighting. 1966 is the year the Vietnam War took off. Took off to nowhere. So, okay. No shorts showing up. P4. She's way off in the good. 915, so it just has to be above the C in the word replace. Okay, so let's see if we can hear this one. Maybe we can hear stuff. Oh man, I've used my clip lead. No, I'm not using it. I'm not doing that. Press P4. Well, noise test doesn't show a thing of any significance, as far as I can tell. So, you know what? Really, this proves the old adage that the real tube test takes place in the item you're working on. And that that's what really counts, of course. The tube testers like this are helpful, but maybe can't really imitate everything that can be a concern when you actually put the tube in an operating circuit. that's what I would say about this. So, interestingly enough, the tube tester was never going to save me, as far as I can see, on finding these two tubes to be defective in the ways they are. I can't even remember now what was wrong with this one, other than, what do they call that? A maracas, isn't it? Maracas? I don't know. I don't know my other words. Oh, whatever it was, just jammed up in there. Hey, the kind of fun you can have doing this stuff. It's really impressive. Well, the last possible thing I can do here is fiddle around with replacing this tube here, because you can replace this. This is a 6J8, and apparently you can stick a 6A8 right in there, and I have a ton of 6A8s. Almost no, I don't think I have any 6J8s. But the thing is, the radio's working fine. Or is it? I think it is. I don't see the advantage of fooling around with this tube other than just for the sake of curiosity, and I'm not like that. Okay. We're going to call it quits here for today. I think that was it. I think that was the exploration I really wanted to do on those two tubes. So I hope you got a kick out of that. That blew away most of the fog. Maybe not all of it. Hey, have a great day.